Good morning, dear students. Let's start the revision of the chapter 3, rotation and revolution. And as already you have studied about rotation and you know about the revolution also. So very quickly, let's start here. So all of you know the rotation, that is the movement of Earth on its axis that takes 24 hours. That is it is known as rotation. And revolution is the Earth which revolves around the Sun, and it takes approximately 365 days and 1/4 days, and this is called revolution. But now let's see here, during the rotation what happened as the Earth rotates on its axis. But what happened, the sun's rays, as it falls on the Earth, it forms a one circle. This circle actually around the Earth, it separates day and night, and this circle is called circle of illumination. Now as the Earth rotates on its axis, there are the different effects can be seen. So first effect is, as the Earth rotates, and it creates a Coriolis force. Coriolis force is what happens as the Earth rotates. What happens? All the moving bodies, that is the ocean currents and the winds, they deflect towards right hand side in the northern hemisphere, while in the southern hemisphere it deflects towards the left hand side, and this is called Coriolis effect. And by the rotation of the Earth as it is created, and that force which creates this effect is called Coriolis force. Now this is also known as Farrell's law. Now Coriolis word actually it gets from the geographer whose name was Gustav Coriolis, and who has discovered this thing, and on his name this effect, this force actually has got the name Coriolis force. Now next is, because of the rotation what happened, all the cyclones and anticyclones, they are also deflected. And one more thing you can find, as the Earth rotates on its axis, what happened, there is one centrifugal force is created. Because of that, you can find the Earth is slightly bulging on the equator. So Earth is slightly bulging on the equator, while at the equator, bulging actually at the equator and slightly flattened at the poles. So this is the effects of the speed of rotation. But if you find here about the speed of rotation, the Earth takes about, first of all, the period of rotation. So this period actually, the exact period taken by the Earth to complete one rotation is 23 hours 56 minutes 4.09 seconds, and this exact time which has been taken to complete one rotation is called sidereal day. So this is the period of rotation and effects of the speed of rotation. Let's see some more effects, as some of effects already you know. And because the Earth rotates, it causes also day and night. And one more thing, as the Earth rotates, you can find what happened during the day, temperature increases, while during the night temperature decreases. And this variation in the temperature is caused by the rotation of the Earth. Now as you can find all the all the celestial bodies, that is sun, you will see the sun rises from the east and it sets in the west. You will find the moon and all the stars also. It seems they are all moving, but actually they are not moving. But as Earth rotates, so it seems that all the celestial bodies, they moves. Another thing, the rotation of the Earth, it also creates a centrifugal force. Already I explained you. And another thing is the alternate rise and the fall in the ocean currents, ocean waves. Now you have in the previous class you have studied about the tides. So these tides actually, They are also one of the cause of the tide is also rotation of the earth. Tides are caused usually by the gravitational force of the moon and the sun, but one other important cause is the rotation of the earth. Now let's see here the Coriolis effect. Already, as I explained you, one French scientist whose name was Gustave Coriolis, in 1835 he has given this theory and he discovered this, and he have seen that all the moving bodies, they deflect right hand side in the northern hemisphere and left hand side in the southern hemisphere, and this is how this effect gets the name, and it is called Coriolis effect. You can find here with this figure here, this is the northern hemisphere, this is pole. So you can find all the this is the wind, but this wind deflects right hand side. So this deflection is caused by the rotation of the earth, and this is called Coriolis effect. In the southern hemisphere, this is south pole, these are the latitudes, circles, and from the south pole, if you see here, the winds will find they all move in the left hand side. Now next is the centrifugal force. What is the centrifugal force? One very common example I can give you. As you take one glass of water and you just stir it with the spoon, and you will see what happens as the water just spins there in the glass, and in the center you will see what happens. The water actually, it just causes a one hole, means one depression in the center. It seems that actually it is just compressing, getting down. So this is one example of centrifugal force. So as the earth also rotates on its axis, what happens? This centrifugal force is created. This is why actually the earth is flattened at the poles. Now next is the revolution. All of you know about the revolution, that the period of revolution is 365 days and 365 days and 1/4 day, right? So total 365 1/4 day that is taken by the earth. We call it a tropical year. The exact time that has been taken by the earth to complete one revolution, that is 365 and 1/4 day, and this is known as tropical year. Tropical year. But usually you will find in the calendar 1/4 days omitted, and only 365 days are taken in a whole year, and this year is called calendar year. And what happened? The 1/4 day is taken together for 4 years, and every 4th year 1 day is added. This is why every 4th year you will find the year has 366 days, and this year is called leap year. The next is the perihelion and aphelion. Let me explain you here. So you can find here, peri word actually is a Greek word, means near. Helion means the sun. So when the sun is very near from the earth, that position, that is called perihelion. While when the earth, it just goes farthest point from the sun, and it is known as aphelion. Now look here, this figure. Now as the earth revolves around the sun, you can find this is the closest distance. It is 147 million kilometer, and this occurs. Now you will see when this thing occurs, the closest, the earth comes closest, but if you will find actually this occurs on 3rd January. So you will find in the northern hemisphere, in India, you will find during this time we experience winter season. So actually the winter and summer, it doesn't actually it doesn't have any relation with the closeness or you can say the distance of earth from the sun. So you can see this is the 3rd January, and the earth is closest from the sun, and this position is called perihelion. But on 4th July, the earth it just goes at the farthest distance from the sun, and this is 152 million kilometer. This position is called aphelion. So this is perihelion and aphelion. Now next, let's see here about the speed of revolution. So usually the earth actually, it just moves with a very great speed, but if you find here, the speed of earth is 30 kilometer per second. So this is the velocity of the earth as it revolves around the sun. Now next, we are going to see about the effect of inclination on the axis, but already you know about the inclination, as the earth is inclined on its axis, and this is about 66.5 degree. So this inclination is 66.5 degree, and this is why what happened, there is apparent movement of sun rays takes place between Tropic of Cancer and Tropic of Capricorn. And this is why you will see afterwards also, when I will explain you about summer solstice and winter solstice. Now during this time, actually we will find that during the summer season, you can see the days becomes very lengthy, while the nights, they become very shorter. But if you will find in the winter season, the days becomes very short while the night becomes very long. So this duration of the day, why this varying length of day and night is caused? So this is because of the inclination of the earth. Now another is this diagram. You will find the earth is inclined. Now this is the one imaginary plane you can see on the diagram on your screen. This imaginary plane on which the earth is inclined, this is called plane of ecliptic. Now let's start here the effects of the inclination of the earth. As the earth, now you can see here this picture, earth is inclined, so, and also revolves around the sun. This is why different parts of the year, the different parts of the earth, it just receives the sun rays at different angle, and this is why what happened, we experience season. So the first effect of the inclination of the axis is the alternation of seasons. This is why we experience the change in the season. Now next is let's see here some most important effects of revolution. The first effect is the changing altitude of midday sun at different times of the year. Now what do you mean by the changing altitude of the midday sun? Now you can note, if you notice during the summer season, if you find, it seems the sun is just overhead. The sun is just overhead and it's very straight, the sun rays, and you can see it's very intense heat we receive, and this is why the season is summer. But during the winter season, what happens, you will see the sun, and you will see the sun rays is falling at a different angle. It's not very vertical, and this is why what happens, as the sun rays enters in a different angle, now it has to travel a long distance in the atmosphere. And what happens, you will see the changing altitude of the midday sun at the different times. This is why winter season it is cold, because the angle of the sun gets changed. So this angle actually, as it changes, so every day there is a changing altitude of midday sun occurs at the different times of the year. Now next is the length of day and night. Already I explained you as you can see, the winter season, the days are shorter, but while the nights are longer. But just opposite, you can notice in the summer season, the days are longer while the nights are shorter. So this varying length of day and night is caused by the revolution of the earth. And the third effect, already explained you, the seasonal changes and their effect on temperature. So you can find the summer, winter, spring and autumn, these different seasons are caused. So why they are caused? They are caused due to the revolution of the earth. around the sun. And as the earth is inclined also, so what happened, the rays of the sun, it falls on the different parts of the earth at different angle. This is why during the summer season what happened, the sun rays are very vertical, so that's why they are very intense, and that's why temperature is so high. While winter season, the sun rays, it just forms slanting rays, that is a slanting angle, and because of that they are not so intense, and you can see the temperature is cooler during winter. Now next is we are going to see about the summer solstice, winter solstice and equinox. So let's see here. So let's see here with this figure. Now in this figure, if you'll find here, this earth actually at different time of the year, they are the 4 positions. Now in this position, if you see on 21st June, what happens, the earth is inclined and the sun rays falls vertical there on Tropic of Cancer. And this is Tropic of Cancer, sun rays is falling very vertical here, and this is why the northern hemisphere experiences summer, while the southern hemisphere it experiences winter. Now this position is called summer solstice. Now what happened on the 22nd December? You can notice it is the just opposite. Now during this position, actually what happens, as you can see, earth is inclined on its axis, so the sun rays falls vertical now on Tropic of Capricorn, and so the southern hemisphere now it experiences summer, while the northern hemisphere it experiences winter, just opposite, and this position is called winter solstice. Now again the two more position if you'll find here. The first one here, if you see on the 21st March, what happens, if you see here in the figure, the sun rays are falling vertical on equator, because even though the earth is inclined, but the sun rays is falling on the side of the earth. That's why here this inclination doesn't play any part, and the sun rays are falling on equator. This is the time actually when the whole earth actually experiences equal day and night, means night is of 12 hours and day also is of 12 hours. That's why this word equinox means equal nights, and this occurs in the spring season. You will see this is the 21st March. In the northern hemisphere it is a spring season, and that's why this position is called spring equinox. But on 23rd September, as the northern hemisphere experience autumn season. Now same thing is just opposite in the southern hemisphere, actually it is a spring season. And whenever this position, the name, this is or you can if you see about the summer solstice or maybe the winter solstice or spring equinox or autumn equinox, they are named after that is northern hemisphere. Now here the sun rays is falling vertical again on equator, but as the northern hemisphere experience autumn season, so this is called autumn equinox. So these are the 4 positions. So this is summer solstice, winter solstice and 2 equinoxes. This is the spring equinox on 21st March and autumn equinox on 23rd September. Now already I explained everything in very detail in the video, and the link I will just share it, and from that video again you can see, and if you want to again want the detailed description, so again you can watch that video. So okay, goodbye.